Welcome back, AI architects. Today we are tackling a critical enterprise design pattern in LangGraph configuration. Specifically, we will master how to pass runtime arguments to your graphs using runnable config, enabling you to build highly dynamic, multi-tenant AI agents. Let's dive in. Let's begin by defining what we mean by passing runtime arguments. When you build a LangGraph workflow, you typically have an explicit state that tracks the conversation history or task data. But what if you want to dynamically change the LLM provider, pass a specific user's API key, or define a recursion limit without polluting your core task state? This is where runtime arguments come into play. Passing runtime arguments means injecting configuration variables into your compiled graph at the exact moment of execution. By doing this, we create a strict separation of concerns. The state holds the business data that evolves over time, while the config holds the static execution metadata and environmental settings for that specific run. This is fundamentally managed by an object called runnable config. Take a look at this architecture flow. On the top left, the user query and business data flow directly into the graph state. This state updates continuously. On the bottom left, environmental variables like model choice or API keys are injected via the runnable config object. During node execution, the node reads the data from the state, but its behavior is guided by the rules and parameters held securely in the runnable config. They work together, but remain strictly separated. To master runtime arguments, we must understand their container, the runnable config. Think of runnable config as a secure envelope passed along with your state to every single node. LangGraph relies on it for native execution control. For instance, it contains built-in keys like recursion limit, which dictates the maximum number of supersteps to prevent infinite loops, and thread ID, which is crucial for loading memory checkpoints. But the real magic for us developers lives in a subdictionary called the configurable key. This is a dedicated space where you can pack any custom runtime parameters you want, like user IDs, selected LLM models, or feature flags. As the graph runs, your nodes simply peek into this configurable dictionary, extract the values using standard Python.get methods, and adapt their logic on the fly. This class diagram unpacks the runnable config object. At the top level, you see system-level attributes like recursion limit, run name, and tags. Inside it, we see the composition relationship to the configurable dictionary. This inner dictionary acts as a payload bay. It holds framework-required keys like thread ID for persistence, alongside completely custom variables like model provider or user API key that you define yourself. You might be asking, why not just add these settings to my graph state? As senior engineers, we must avoid state bloat. If you put a model name or an API key into your core state, every node transition processes that data, and checkpointers persist it needlessly. Configurations solve this by being immutable per run. The configuration stays static while the state mutates. This unlocks massive reusability. You can compile your graph once, lock it into memory, and then serve 1,000 different users concurrently simply by passing a different config to each .invoke call. Furthermore, this provides a security boundary. Keeping sensitive credentials like API keys or internal database routing IDs out of the conversational state ensures they are never accidentally logged, exposed to the LLM directly, or permanently saved in a memory checkpointer. Observe the reusability pattern here. We have a single compiled graph residing in memory. User 1 and User 2 both send requests simultaneously. By passing different runtime arguments, the single graph orchestrates two entirely different execution instances. User 1's flow is routed to OpenAI with thread 123, while User 2's flow uses Google Gemini with thread 456. One architecture, infinite dynamic variations. Let's look at how to implement this in code. It requires a slight adjustment to how you define your nodes. Normally, a node function just accepts a state parameter. To unlock runtime arguments, simply add a second parameter typed as runnable config. Inside the function body, you navigate into the configurable dictionary and use the .get method to safely extract your custom variables, ideally providing a fallback default. Look at the sample code on the slide. The GenerateApp node pulls model name dynamically from the config. If it's missing, it defaults to GPT-4o. It then uses this string to select the correct LLM from a dictionary of initialized models and proceeds with the invocation. This is a deep architectural win. You are hot-swapping heavy dependencies at runtime without ever rewriting the node's core logic. This sequence diagram maps the internal node execution. The graph engine triggers the node function, handing it both the state and the config. The node immediately queries the config dictionary for the model name. The config replies with Gemini 2.0 Flash. The node dynamically selects the Gemini model, executes the inference against the state data, and hands the freshly generated state updates back up to the graph engine. Now that our nodes know how to read the configuration, how do we inject it from our application? The implementation on the invocation side is incredibly straightforward. Whenever you call .invoke, .stream, or .batch on your compiled graph, you pass your initial state as the first argument, and you provide a config dictionary as the second argument. Inside this dictionary, you declare the configurable key and nest your custom runtime variables inside it. You can see the syntax on the slide. Crucially, you can mix native LangGraph settings with your custom variables in the exact same payload. In the bottom example, we set a strict recursion limit of 10 to protect our infrastructure, while simultaneously passing a thread ID to load conversational memory and a custom tenant ID of Acme Corp. to drive our proprietary business logic. Follow the data flow from an external API request. An API request comes in specifically for the Acme Corp tenant. Our backend script intercepts this and uses it to build the config dictionary. This config payload, alongside the initial state containing the user's message, converges at the graph.invoke method. From there, LangGraph takes over, carrying that configuration safely through the entire execution pipeline. Let's apply this to a real-time, highly profitable enterprise use case, a multi-tenant agent architecture. Imagine you are building a B2B SaaS platform that offers an AI data analyst to hundreds of corporate clients. The challenge is immense. Client A demands OpenAI, Client B demands Google Gemini for compliance, and obviously, Client A must never see Client B's database. If you hardcode this, you'd have to deploy hundreds of separate agent instances. The solution is passing runtime arguments. We deploy exactly one compiled LangGraph. When a user logs in, our API dynamically constructs a runnable config containing their tenant ID and model preference. During execution, the nodes use the tenant ID to construct isolated database connections and the model preference to route to the correct LLM. The result is extreme scalability, guaranteed data isolation, and a massive reduction in server memory overhead. This flowchart is the holy grail of SaaS agent design. We have two distinct users hitting the exact same single compiled agent. Because their requests are wrapped in distinct runtime configurations, the agent dynamically bifurcates its backend operations. Client A's path securely queries database A using GPT, while Client B's path queries database B using Gemini. The state machine remains the same, only the runtime context shifts. In our final deep dive, we extend this concept beyond graph nodes to the tools themselves. In LangChain, custom tools can also accept runnable config. This is an absolute game changer for security. Imagine your agent needs to call a third-party API that requires a user-specific OAuth token. If you pass that token into the graph state, the LLM might hallucinate and accidentally print it in the chat. Instead, you inject the OAuth token via the config at runtime. The LLM simply decides to use the tool. The tool function then secretly reaches into the config, grabs the token, and securely executes the API call. The LLM never even sees the secret. In summary, runnable config is the vital bridge between your application's secure infrastructure and your internal agent logic. It makes your agents adaptable, scalable, and safe. I invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Keep building. Our final diagram illustrates this secure tool execution pattern. The graph invocation injects a secret API key into the runnable config envelope. The LLM knows the tool exists and requests an action, but it knows nothing about the keys. The tool function activates, securely pulls the key directly from the runnable config, and executes the call to the external secure API. The LLM stays blind to the credential, ensuring enterprise-grade security.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. We have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks, you can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.